Woohoo! What a good day to be in geometry. Today's date is Wednesday, September 18th, 2019. We are on lesson 1-9. We are talking about polygons today. This is a fun lesson today because it's basically one giant puzzle. And I like puzzles because that's really what math is. So we get some real tastes of math at the beginning of this lesson. Of course, we need to review yesterday about triangles, but is there a quiet raised hand who can get some XP from Jose? Who can read the objective, Jenny? Yeah, so 4 more sides. So if I give you a polygon that has 100 sides, you need to be able to tell me how many degrees the inside angles add up to. I know a triangle is 180. What about a trapezoid? What about something like a pentagon? What do those add up to? It's not 180. It's harder. So let's do this. Another quiet raised hand. Interior angles of a triangle sum to how many degrees? Oh gosh, no one remembers this from yesterday. I did that fancy proof with hearts, stars, and smiley faces. Julian? 180. You have to have this memorized. By the way, if you have your card, you're passing around to Jessica, then Monse, and then Monse will put it in my inbox over here. Your card needs to be turned into me. I gotta collect them all, Pokemon. All right, so challenge. I want you guys to be drawing the fewest number of triangles that will split up the shape. So obviously I could do like 100 triangles. It could be like, okay, triangle there, triangle there, triangle there. I want the fewest number of triangles that can make this polygon split up into triangles. Give it a shot. Go for it. The fewest number of triangles.
Mr. Sindel, do you have a pencil?
Yeah. When you're done with this pencil, I want you to sharpen it and put it over here in the velocity pad. All right, do it again for the second shape. The fewest number of triangles. You're looking for the lowest number.
I did it in 2.
The smallest number of triangles. Can you do it in 1? Obviously, no.
I did it in 1.
The fewest number of triangles. Quiet raise hand with a card that can tell us what the pattern is. Andres.
So, up on the board, or?
You just say out loud.
So, if you guys see the vertices, you will see that on the right one we have 5, and on the left side we have 7. And the number of triangles on the right, like the right polygon, there's 3, and on the left one there's 5. Or yeah, 5. I mean, there's 5 vertices on that one, 7 on the other one. 5. So what's the difference? 7, 5, 5, 3. Well, you might be asking yourself. So you would have to add by 2, like 2 triangles, just to get to the. See, if we had another one, if we had another polygon over here, we would have 7 triangles, and we would have 9 vertices.
What?
Okay, so the pattern is,
Add by 2.
again, if you're uncomfortable with the word vertice is the same thing as points. So he's saying if you have, for example, 9 vertices, then you'll have how many triangles?
11.
If you have 102 vertices, you'll have 11.
I mean, you'll have 7.
7, okay. If you have 102 vertices, then you'll have how many triangles?
100.
If you have 130 vertices, you'll have?
128.
So you're just subtracting 2, and that is the number of triangles. So the way that we're going to say this in math, so make sure, Jose, that you're giving Andres his 50 XP. If you, yeah, you want to just run there and grab it? If you have n points, that's how I'm going to write this. If I have n points, so that n could be 7, it could be 120, it could be 1,000, I don't know, but it's just n right now, it's a variable. Then I also have how many sides based on n. Is it n plus 1, n minus 1, is it just n? If I have n points, or n, I like the word vertices. I'm going to cross this out and make it that vertices. If I have n vertices, how many sides will I have? Is there a quiet raised hand that can tell me how many sides I will have if I have n vertices? And think about that. If I have, for example, this one is a pentagon. It's not regular. It's not nice and symmetric. But if I have 1, 2, 3, 4, 5 points, 5 vertices, how many sides did I have? Is there a quiet raised hand? If I have n vertices, then I have how many sides? There's no quiet raised hand. Andres?
-2 or -n or -2.
None of those actually, but you can still get XP for trying. So Jose, can you give him the 20? I'm going to give us the answer. If I have 5 points or 5 vertices, then I have 5 sides. I have the same number of sides. Vertices are points, and sides are the same thing. Vertices and sides, they're the same number. So if this is n, this also has to be, shout it out,
Negative n.
n. The number of vertices is the same thing as the number of sides when I'm talking about polygons. And then Andre said, if you just take vertices and subtract 2, you'll get the number of triangles. So if I had n, I'm going to do what to n, Andres, to get the number of triangles?
-2.
There it is, n minus 2 triangles. That is your pattern. Count the number of points, or the number of vertices, or you could count the number of sides. Then subtract 2, that will be the number of triangles. Your final step is, well, I counted the triangles, now I need to multiply by 180. You have to do a little bit of math. So let's go ahead and actually do the math for this one. This one had 7 sides, is that right? 1, 2, 3, 4, 5, 6, 7. This one had 7 sides and 7 vertices. So we're going to say that up here, n was 7. N was equal to 7. That means I have 5 triangles. You can see 1, 2, 3, 4, 5 triangles. Now I need to do 5 times 180. So do some scratch work off to the side. You can do it with me. 180 times 5. I don't think on Khan Academy you have a calculator, but I can double check that. 5 times 0, 0. 5 times 8, 40. Carry the 4. 5 times 1 is 5, plus 4 is 9. That means the sum of the interior angles for this polygon, I'm talking about this angle plus this angle plus this angle, all of these angles added up should be 900 degrees. Let's put a giant 900 degrees up here. Let's try this one.
Every polygon?
Every polygon is going to follow the same pattern. We're finding the pattern. That way, when I get all the way to the back side, if I say I have 12 sides, or 120 sides for that matter, I can immediately do the math without having to actually count up the triangles. I mean, I'm still counting the triangles in my head, but there's a faster way of doing this. I'm trying to show you that shortcut. I'm trying to help you find that shortcut on your own. This one had 5 sides, so I should have 1, 2, 3 triangles, because I do 5 minus 2 to get 3 triangles. Now I do 3 times 180. So 180 times 3, 3 times 0, 0. 3 times 8, 16. Carry the 1.
Oh, teacher.
Oh my gosh. Cannot do math. Andre, Sergio, log it. 3 times 8, 24. Carry the 2. 3 times 1, 3, plus 2 is 5. This one adds up to 540 degrees. So again, the process, making sure that everyone can understand. Count the number of triangles. It should be the number of vertices minus 2. Once you get the number of triangles, each triangle has 180 degrees, so multiply by 180. Okay, give me a fist of 5. How well are you following? Because I can't get everyone to participate. This is how everyone participates. 180 degrees per triangle. How well do you understand this whole process? If I gave you a 120-gon, a polygon with 120 sides, could you tell me exactly how many degrees there are? Give me a fist of 5. How well do you understand this process? You have a, how many fists of 5? A 9, a 5, 4, 4, 5, 4, Gunner. A 1? You're not getting this at all? A 10? All right, and everyone else has 4s and 5s. Okay, let's try it out. Well, let's make our formula just so that we have something to fall back to. If you have to make a note card and these are too hard for you to remember, the whole process, let's say that n is equal to the number of vertices. And if you don't like the word vertices, again, change that out for points. Number of vertices. Then the formula to find the sum of interior angles of that polygon will be, well, what did I do first? If I have n, I had to find the number of triangles. What was the number of triangles? We just wrote it up above. Is there a quiet raised hand? What was the number of triangles in terms of n? Is there a quiet raised hand out there? Just read the line up above that. Is there a quiet raised hand that has a card? I'm looking for a card. Oh yeah, Fernando. N minus 2. This now represents the number of triangles. Thank you, Fernando. What was the next step? I have the number of triangles. I need to multiply that by something. Is there a quiet raised hand that has a card? Sergio.
Times 180.
Times by 180. There it is. There's our fancy-pantsy formula. It doesn't mean very much. I don't like formulas. I like the process. I like the process of counting triangles and then multiplying by 180. If you can't remember that process, here's a formula. Count the number of vertices. Do that minus 2 times 180. You have a formula. You have the method. We have two different ways of getting to the same answer now. All right, let's try out our process, hopefully not the formula, on example number 1. Do this by yourself. And then after you finish, check with your elbow partners to the left and to the right. All right, quiet raised hand. Who can do the whole thing for me? Jose.
So there's 6 verses.
6 vertices, I believe you.
And then we do the minus 2.
Okay,
And we get 4.
okay.
180.
Okay, so you did 180 times 4 and you got what?
720.
720 degrees, so the answer is 720 degrees. Again, we counted 1, 2, 3, 4, 5, 6. 6 minus 2, 4. Okay, questions. Give me a thumbs up or thumbs up, or thumbs up or thumbs down. There you go. Did you get that answer? Did you get 720 all by yourself? Thumbs up, thumbs down. You can do thumbs in the middle if you got a little bit of help. Monse, are you okay?
Yeah.
You got this by yourself? All right. Cool. Let's go on to example number 2. Now I don't even give you a picture.
It's already done.
It's already done? All right. Give everyone at least a minute and then Gunnar will do this for us. All right, Gunnar, tell us how to do it.
12 minus 2 is 10.
12 minus 2 is indeed 10.
Okay. It's 180 times 10.
180, and you use the trick of multiplying by 10, move the decimal. Move the decimal right there, so it's 1,800, because that would be a 0. And there is our answer. Make sure you have your units in degrees there. Thank you, Gunnar. 50 XP to Gunnar. And Gunnar can turn in his card. How many cards did I get today? I'm just curious. I got 1, 2, 3, 4, 5, 6. And that's Gunnar's card. 7 out of 12. We'll do better next lesson. All right.
We didn't catch